Okay. This is the volume of a solid of revolution by the cylindrical shell method. So we have our bounded region. We're going to take a bounded region and we're going to revolve that region about the y-axis. So they're going to describe a region here for you guys where you have some function over some closed and bounded interval. So your volume by cylindrical shell formula that we proved already is what you see here. So this is going to be simply a demonstration for the applications of this proof that we did. So the key idea here, though, in the use of the formula is you're going to need to determine both a radius and a height when you revolve a curve about the y-axis. And that's going to be the radius and the height of the cylindrical shell. So we need an R, we need an H. So very often your R is going to be X and the H is going to be F. Don't forget you have the multiple 2 pi here. So this is really, in my mind, I always think of this as 2 pi R H dx. And they're just actually going to factor out the constant 2 pi. And so everything that I just kind of remarked on here is what you see, radius and height. So, okay, this is going to be the applications of the proof. So we're going to start with the first type here. Of course, your region can be described as a function of y, and the rotation can be about the x-axis. In that case, we still use this formula here. However, it's going to be 2 pi r h now dy. And this is what you see here. And in that case, again, we'll see how the radius value here will be the y variable, and then the height here is going to be the function here. So the height's the function, the radius is the y value. We're going to take a look at the details of this in this demonstration. So for the first question that says find the volume of the solid generated by revolving the bounded region defined by the graphs below, and you're going to rotate about the y-axis. So here's the parabola here, y equals x squared plus 2x. The x-axis, the line x is 1. So that's a vertical line. The x-axis is really the line y equals 0 here. So what they're going to describe for you is this particular bounded region now in this picture. So yes, you have that y-axis. The vertical line where x is 1. And you got the curve. Y is x squared plus 2x. So here we go. So we're going to rotate this about the y-axis. And what you will see here, I always draw the approximating rectangle here. So by the approximating rectangle, what you'll end up doing, if you revolve that bounded region that was described here, you're going to end up getting, if we just take a look at the approximating rectangle, you get what we call a cylindrical shell. This is the cylindrical shell. So I want to write that down, and that's why they call it the cylindrical shell method. Okay. So you're always going to need to get two values. You need the radius value and you need the height value. Keep in mind, you rotated about the y-axis here. All right, so now how do we get the radius value? Well, you want the radius here of this cylindrical shell, and that's going to be the distance, really, if I look at it this way. That's going to be a horizontal distance. That's going to be what we call the radius of this cylindrical shell. So if you kind of can imagine that vertical distance we call r. Now that r value is a corresponding value of x in the interval of the region. So r here is going to be that x value. So that's your radius of your cylindrical shell. It is the horizontal distance. The height of this cylindrical shell, right? If I say, okay, how tall is that rectangle now, which will be the equivalent to the height of your shell, well, that's going to be the value of the function. And sometimes we say, well, h is the y value. Well, okay, h is the y value, or it's the value of the function. And all you're finding is really two values. The radius value here, and maybe I'll just do it this way, and maybe do it up here, but it doesn't matter. Okay, and that's a corresponding next value for the radius. That's the length of that from the axis of rotation to that arbitrary line in the middle of that rectangle. And this function of y is going to be x squared plus 2x. So, okay. So let's put this down here. Your radius is x. The height, which is the y coordinate, or the value of the function, is x squared plus 2x. Now, this is what goes in that formula. V is the integral of 2 pi RH dx. So remember, you're going from 0 to 1 here, because you're going from the x-axis to x is 1. So that interval goes from 0 to 1. So we just have to plug our limits now. Make sure we enter both the radius value and your height of your cylindrical shell here and here. So you end up with 2 pi x squared plus 2x dx. Okay, you're going to pull out your constant 2 pi. You get x squared plus 2x dx, and this is what we're going to integrate this. Okay, so this is where we're going to perform our, oops, we forgot an x. I apologize here. Don't forget there's an x there. So we can't integrate yet, but we're going to. Let's just kind of remind ourselves what we're looking at here. Okay, you got your radius, you got your height. Now you're going to need to do a little algebra. Two pi integral x cubed plus 2x squared. Now you can integrate. So I'll just kind of put this over here, I guess. So let's keep everything here. Two pi 1/4 x to the 4th plus 2x cubed over 3 evaluated from 0 to 1. Okay. 2 pi. Now, this is going to be, let's go through this, let's go through the process. Remember, this is going to be our antiderivative. So we got to take the difference f1 minus f0 here, and we'll have 2 pi, 1/4, 1/4, plus 2/3, 1 cubed, minus 2 pi, 1/4, 0⁴, plus 2/3, 0 cubed. That'll give you 0. Two pi 1/4 plus 2/3. All right, now let's use that algorithm here, that shortcut formula for adding unlike fractions here. Okay, we're going to cross multiply, and then we're going to multiply here by on the bottom there. So here's what we get. 3 plus 8 over 12. So this will be 2 pi times 11 over 12. And we can cross out the 2. That'll be a 6. We end up with 11 pi over 6. All right. All right, so there we go. Just checking a few things here. Let's go over to the next question now. And that's going to be somewhat similar, number 2. However, this is going to be a little bit of a difference now. So the bounded region now, they're going to give us some curves here. We got a parabola, looks like y is x squared. Let's see what this bounded region looks like. And then we got the line y, it's really a linear equation. Y is 12 minus x. So we see both the parabola in I guess it's purple, and the line in black. Then they're going to say to the right of the line, x is 1 now. So they gave us a line here. This is the vertical line that x is 1. So if they want us to describe a region, the region here that they're talking about is right in there. All right. So again, we're going to revolve that region about the y-axis here. So let's take a look. And when we do, that approximating rectangle is on the other side there. We generate a solid. And I'm just going to draw this approximating, well, I'm going to draw here what we call that is our cylindrical shell. So let's keep track of 2 things again that we always need. We need the radius. We need the height of the cylindrical shell. So let's be careful now. This is the line. X is 1. Here. So we can solve this equation, looks like over here. This will be 1, 2. This looks like x is 3. We can solve this quadratic. We can set the curves equal to each other. right? This is the first curve and the second curve. We can find the points of intersection. So this will be x squared now plus x minus 12 is 0. Factor x plus 4, x minus 3 is 0. We get x plus 4 is 0, which means x will be negative 4. We get x minus 3 was 0, which means x is positive 3. And then sure enough, we found the 2 points of intersection. Okay? So this is going to be important to know because we're going to use our volume by cylindrical shell formula, but the limits are going to be from 1 to 3 because this is the region they described for us in blue there. Okay? All right. Yeah, it's to the right. Your region is to the right of the line. X is 1. There it is. So I want to share with you guys again, the radius is from the rotation axis, which is the y-axis, to somewhere you can think of arbitrarily in the middle of this approximating rectangle. The point is it's going to be some x value. This means the radius is between 1 and 3, that x value. So r is going to be x. The height now is interesting. So what I want you guys to remember now is this. We got to find the height here. Maybe write it down this way. This distance, that top distance, and then the bottom distance. So that height's going to be y top minus y bottom. Okay, it's the top minus the bottom. The top curve is the line. So this is going to be 12 minus x, and the bottom curve is x squared. So I need to do the top minus the bottom. So the line was black, okay, and then purple was the, looks like it's the quadratic. So you're going to end up now with the height being simply 12 minus x squared now. All right, let's get the details here. We got the radius value, that's going to go here. And we got the height, which is going to be the difference between the two curves there. So just point out to you, just to kind of emphasize, we have this distance. That's your height. Okay, the height is this vertical distance from here to here. Top curve minus the bottom curve. I painted that blue for this exercise now. So let's kind of plug everything in. Let's bring out, if you will, the constant 2 pi. And we're going to integrate from 1 to 3. Your radius is x, and that height will be 12 minus x squared dx. And now you're going to do your algebra. You're going to distribute. So the volume will be 2 pi, 1 to 3, 12x, minus x squared, minus x cubed, dx. So this is how we do our, I guess volume by cylindrical shells. All right, now we get to integrate. So let me do something here. We're going to integrate over here. All right. 2 pi. Let's see what we get. 12x squared over 2. 1/3 x cubed. Minus 1/4 x to the 4th. From 1 to 3. So we got our antiderivative function. And this will be f of 3 minus f of 1. Okay, so let me just kind of simplify here. That's 6x squared minus 1/3 x cubed minus 1/4 x to the fourth from 1 to 3. Okay. So we're just going to evaluate the limits. Okay, so let's try some of this out. 2 pi now. We got 6 times 9 minus, this is actually going to be minus 3 squared. Then minus 3 to the fourth over 4. Minus 2 pi. 6 minus 1/3 minus 1/4. All right, let's do our arithmetic. 54 minus 9 minus 81/4 minus another 2 pi. 6 minus 1/3 minus 1/4. So I'm going to do some simplification. Let's see. 54 minus 9. Looks like we're going to get 45 minus 81/4 minus 2 pi times 6 minus 1/3 and minus 1/4. Let's get out our... All right. Now, I could do a couple of things here. What I think I want to do is I'm going to factor out the 2 pi from both terms here. So you get 45 minus 81/4. Then it's going to be a minus 6 plus 1/3 plus 1/4. Because I'm going to really distribute right over here with the negative sign, okay? But I factored out the 2 pi. This makes my arithmetic kind of a bit easier. 45 minus 6, looks like that's 39. And then it's going to be minus 80/4 because I'm going to combine these two whole numbers and I combine these fractions. Then don't forget, we're going to add that 1/3. However, this becomes 20, I believe. So it looks like we get 2 pi 19 plus 1/3. All right. So we got a whole number plus a fraction. Multiply the top by 3 and the bottom by 3. You get what? 54/3 plus 1/3. So it looks like we get 2 pi times 55/3. This is really 110 pi over 3. And that's what I got with this one. I'm not sure. Let me double check something here. We might have had an arithmetic error on this. Let's see if we had an arithmetic error on this one. 6 times 3 squared, 954. Minus 9 minus 81/4. Right, you guys can double check. Hopefully we're correct with that one. All right, now we're going to do another question. We're going to revolve around the what? Around the x-axis. All right, hopefully we didn't make a mistake in the arithmetic, but the process looks good. Okay, the bounded region. Notice what they gave. They gave the curve x equals the cube root of y, and that's in blue. They told us the region is the y-axis. That's right in here, the y-axis. Let me get a pencil. All right, the line y is 8. This is in purple. This is the line y is 8, by the way. So this defines a region. So I guess we can see that region here. Okay, this is the region they're going to rotate about the x-axis. Now, I want to point out the y values. Y is going to vary from 0 to 8 because this is this location here. This is the y is 8. So if we look at that y value and the fact that x is a function of y, we're rotating about the x-axis. The volume by cylindrical shells is 2 pi RH. This will be dy now, okay? This will be dy. You're rotating about the x-axis. This is the second formula here, way back in the beginning, essentially. And we did do this where we have the difference of the top and bottom, but you guys could look that over in the notes there. But we're looking at this this shell method, cylindrical shell, and it's the same process, but y is from C to D. Okay, so everything gets kind of switched in terms of the variables. You go, what do you mean by that? Well, what's going to happen now is instead of your radius being an x value, we're going to see that the radius will be a y value, and the height's going to be the x value, which is a function of y. So I'm just going to put it maybe over here. So everything actually kind of gets switched because of how they gave everything to us. And then take a look at the cylindrical shell now. That shell, this approximating rectangle, gets rotated about the x-axis. So this is what I want you guys to see. And yes, my pictures are not the best. That's why I do all the graphics there. And the radius, again, let's do this radius here, is now going to be, we're rotating from the about the x-axis down over here. Okay, so I want you guys to see that this, now your radius is going to be this value here. That's the radius of the cylindrical shell. It's going to be a y value. The height is going to be that distance here of the shell. Or let's go back up here. This is the height. So you have the height being the curve, if you want to think of it this way. Your height's going to be the curve cube root of y minus that 0. It's going to be the right value minus the left. So your height, you can think of yr minus, and it's not even yr, it's xr minus the xl here, okay? Right and left, where this is the 0, because they said it's the x-axis, that's the line, x is 0. So your height's going to be, like we just said, even if we do the, right minus the left, now you got your height. All right. Let's remind people. Your radius, and then you get your what? Your height. So just plug these in. Radius is y. Height is the cube root of y. So let me do more here. Remember, this is from 0 to 8. So that's going to be our limits, 0 to 8. Okay. pull out your constant. This is going to be y to the 1, or the 3/3. Becomes y to the 4/3 dy. All right. Nice integral. Okay. Y to the 3/3 plus 1. This would be 7/3 over 7/3 by the power rule. You get 2 pi now times 3 over 7. Y to the 7/3, 0 to 8. Let's see. Sorry, that's going to be 6 pi over 7 now. I'm going to simplify this. This is y squared cube root of y. Okay, I'm going to simplify by the method I demonstrated to you guys here how to do that, right? Write it as a whole number. Right? 7/3 becomes 2 1/3, or 2 plus 1/3. Those are the powers of your exponents there. So, okay. So now that should make everything a lot easier to evaluate, meaning 6 pi over 7, 8 squared, cube root of 8. Six pi over 7, 0 squared, cube root of 0. This makes this whole thing 0. And the cube root of 8 we know is the value 2. All right, let's see if we can do some arithmetic with this. So this is 6 pi times 64 times 2 over 7. Okay. So I guess we just have to know what is 6 times 64 times 2. All right. Let's see what that is. Let's get this dog to stop barking. 768 pi over 7. I double check my work. Anyway, well. So you get to yell at the dog, then you lose your pen. Here we go. Yeah, it looks okay to me. Did I do my right arithmetic? Y to the 4/3, y cube root of y? Yeah, I think so. All right. All right, number 4. Similarly, we have what? X is 4 square root of y. The y-axis, this is the line. X is 0, and the line y is 4 here. So yes, you can see this curve here. This is the bounded region. You're going to rotate about the x-axis. All right, notice your y values are good from 0 to 5. That's going to be how we integrate here. So we're just putting together the bounded region they're describing. Okay, so let's remember our cylindrical shell formula. Volume 2 pi. We're going to integrate from 0 to 5. Let's do it all together here, just in case. It's easier for me to remember 2 pi RH. This will now be rotating about the x-axis. That means this is a dy. Okay, and this is my radius value here, these y values. The height is going to be this distance now. So I just want to kind of remind you guys, your height here is going to be the curve on the right, which is the fourth. Actually, that's not a index. It's 4 square root of y minus the right curve will be 0, but we don't even have to write that down. R is y, so we just have to plug everything in now. I don't even have to rotate that curve. I'm just going to go straight to our formula here. We know we're going to go from 0 to 5. So we can pull out the 2 pi, integrate 0 to 5. R is y, 4 square root of y, dy. We get 8 pi, we're going to integrate 0 to 5. Y, square root of y, dy. So if you kind of lost track, let's go back and kind of give it some color so we can see everything. This is what we're looking for. Remember, this is the height here. That length, it's the XR minus XL. All right. For any y, y is between 0 and 5. All right. So algebraically speaking now, 8 pi, you get y to the 1/2 dy. All right, this is what we have to integrate. Okay. All right, let's see. So let's see what we get now. 8 pi, y to that 3/2 plus 1, that's 5/2. Let's go through this here. 8 pi times 2/5, y to the 5/2. I'm going to simplify that again. Let's see, we get 16 pi over 5, y squared, square root of y from 0 to 5. 16 pi over 5, 5 squared, square root of 5, minus 16 pi over 5, 0 squared, square root of 0. This portion here becomes 0. So looks like we're going to get an opportunity to remove that. So 16 times 5, I believe that's 80 pi square root of 5. Anyway, double checking here. Hmm. 8, 2, 16, 5 pi y squared. We simplified over here. You guys remember this? 5/2 is really, remember, I think 5/2, let's double check here. 5/2 is really 2 1/2. Yeah, so it looks like we're good with that. Power 2 and then 1/2. Plug in the 5. Was that 0 to 5? Oh, I think we screwed up here. This is what it is, 0 to 4. All right, that's where, well, you know, let's just change. Now we'll use 0 to 4. Okay, let's just be, I don't want to change the sheet. Let's double check. Yeah, 0 to 4 was the limit, not 0 to 5. So let's make sure we emphasize that idea. This is This is truly your radius from 0 to 4. It even tells us there. All right, I guess the 5 stood out. All right, change that to 4. 4, 4. That's going to change our answer. I knew something was bothering me. Let's try that again. 16 pi 4 squared square root of 4 minus, don't forget to divide by 5. 16, all right. 0 squared is 0. Portion here is 0. (16 pi 16 times 2 over 5). Now that's going to be a pretty interestingly big number. 16 times 16 times that 2 gives you 512. So your final answer is 512 pi over 5. All right. All right. Number 5. What are we doing here now? Let's see if we can make some sense with this. All right, we got a bounded region now. Looks like we have that parabola, which is black. Y is x squared, and then we have another parabola, which is purple. So these are the two curves there that we see. And now you're gonna rotate this region. So we're really looking at the intersection here. The intersection is right in here. Okay. The intersection. This is the region. This is what we call the bounded region. And they're going to rotate now. This is your rotation. It's a line. X is 3. That is a vertical line right in here. This is the line x equals 3. So let's write it in red and emphasize. So vertical line, x is 3. Now, this is going to be similar to what we've done before, but we're going to rotate about that line here. And what you end up getting is once again, I didn't draw it in the other picture here, but I want you guys to see this here. Oh, it's not on that side though. It's on the other side because we're rotating about that line. X is 3 here. So you end up here with the cylindrical shell. Now, this is going to be interesting. The shell looks like this now. All right, just texting my wife. Now, okay. So we're going to have to know something about what's going on here. This is the line x equals 3. It's not the x-axis. Again, we have the same exact formula where your volume will be the integral of 2 pi RH. We're back to dx. Okay. All right, so we need the radius and we need the height now of the cylindrical shell. So let's be careful here now. Okay, so I want to remark about two things. We need to know what this radius is going to be. Okay, so this is a value of x between these two numbers over here in black. We just don't know what they are. That's the point of intersection. So we set the two curves equal to each other now. If I can get this, I don't know what this is. So x squared is 4x minus x squared, and we solve for x. Translate 2x squared is 4x. 2x squared minus 4x is 0. 2x, x minus 2 is 0. 2x is 0. X minus 2 is 0. This means x is 0, and it means x is 2. All right. So 0 to 2, I just want to let you guys know that this is the x coordinates for this bounded region here. X is between 0 and 2, so our integral would be from 0 to 2. All right. Okay. So how do we get the radius now? The radius here is going to be the distance from this 3 to x. Let me see if I can draw that here for you guys. Very kind of go back here. Okay. How do I find, it's not that hard, the distance from 3 to some x value? Well, it's a horizontal distance. You take the right value, which is 3, and you subtract the left value, which is x. So we're thinking of it as, what's the difference between these two lines? What's the distance between these two lines? Well, that's 3 minus x for the radius. The height on the other end is now going to be how tall? What's the height now? This distance here is the height. Your height now is going to be the top curve minus the bottom curve, and they're both in terms of y. So that's going to be y top minus y bottom. We just have to determine which is the top curve. It's the parabola that opens down, and the bottom curve is the parabola that opens up. So the one that opens down is purple. The one that opens up is black. So x squared minus, this is the height now. X squared minus 4x minus x squared. So your height really becomes 2x squared minus 4x. So radius value in the height over here. Okay. Let's see. We're going to have some algebra here to do. R is 3 minus x. The height, 2x squared minus 4x, and then that'll be our dx. So let me give you guys this color here. Radius and your height there. And let me double check. Oh, I have it backwards. It's 4x minus x squared. Okay, we have it backwards here. Just be careful. I'll show you what I mean. All right. Okay, the top curve is purple. The bottom curve is black. So the top curve is purple and the bottom is black. We see it there. All right. So it looks like we're just going to have to do some algebra now here. Let's distribute, we're going to work with a 3 here. Let's do some algebra. Let's do the 3 multiplied by both terms, and then we're going to use FOIL here is what I'm saying. Let's just do FOIL. How's that? Let's write it down here. First, outer, inner, last. So 12x plus 2x cubed minus 4x squared plus 2x cubed. So 12x minus 4x squared plus 4x cubed. Okay, so we get 2 pi. We integrate 0 to 2. 12x minus 4x squared plus 4x cubed. I can actually factor out a 4, I guess. And you get 3x minus x squared plus x cubed. Let's pull out that constant 4. So the volume is going to be 2 pi. Let's integrate. Don't forget the 4. 0 to 2. 3x minus x squared plus x cubed dx. 8 pi. All right. Let's just double check we did FOIL okay. 4x minus 2x squared, 3 minus x. Let's see, did we do FOIL okay? Let me double check. First term, 12x minus 6x squared minus 4x squared plus 2x cubed. 12x minus 10x squared plus 2x cubed. Okay. Looks like my FOIL is all messed up. Let's factor out a 2 since we're at it here. 6x minus 5x squared plus an x cubed. All right, that looks good. So this, I'm going to pull out this constant 2. Dx. Okay, let's simplify here. All right, so if this is f of, we get what? F of 2 minus f of 0. Two squared is 4 minus 5/3 times 8, okay, plus 1/4 times 2 times 16. So we're going to do some arithmetic here. 12 minus 40/3 plus 4. 16 minus 40/3. Okay. And we can take a whole number and subtract a fraction. Okay. For pi. 48/3 minus 40/3 gives you 8/3. 32 pi over 3. All right, I think our arithmetic is okay, though. Yeah, we had to double check that FOIL. Something was off on that one. Anyway, all right, we're in the last one. All right, let's see what our time's like here. Okay, last one. Look at the bounded region. The curve y is x squared is a parabola. The line x is 0, the line x is 1, and the line x is 2 here. And then we're going to rotate about another line that x is -2. So, okay, we see the parabola. Y is 0 is really the x-axis. All right. And x is 1 and x is 2. I think in this picture there's a typo. No, there's not. This is where the region is. There's not a typo. Here's where 2 is. Here is where 1 is. All right. There's no typo at all. So these x values, okay, are going to be between 1 and 2. So 2 pi r h, we're going to rotate about the line x is -2 over here. That's what this is. There's no typo. This line x is -2, a vertical line, so we got dx over here. All right. We're going to get a cylindrical shell. If I look at that approximating rectangle, that's going to be all the way on the other side here. And you need to find a radius value again. And I don't know, maybe we can draw something similar so you guys can see that. I don't know if that just distracts you. We need the height, which is going to be the easiest thing to find. Right? Our height here is just going to be that parabola, it looks like. X squared. So that one's easy. We got the height. The radius, though, remember, this is a line x is -2. How do we get that radius of that cylindrical shell? That's a point here to here. Now, it's kind of simple. The right value is x, and the left value is -2. So your radius is going to be x minus a negative 2 because it's always the right value minus the left value. So some arbitrary value of x on the right side over here minus the x is negative 2. So this is what we have, x minus a negative 2, which will be x plus 2 for your radius now. The right value minus the left. That's x plus 2 now. All right. Here you go. And that's going to go from 1 to 2. So the volume here is going to be the integral of 1 to 2 pi. Don't forget what your radius is. X plus 2. What's the height? X squared. All right. So there we go. So the height was easiest to get. It's just how tall that rectangle is. And then the distance, right minus left. Let's do some algebra. Pull out the 2 pi. Get now x plus 2, x squared, distribute 1 to 2, x cubed plus 2x squared dx. Distribute. All right, let's integrate. How would it happen? Come on. Okay, let's integrate. 1/4 x to the 4th plus 2/3 x cubed. Evaluate that from 1 to 2. Okay. All right. So we're going to do a little bit of arithmetic. Looks like it's 4 plus, what is that, 16/3. And then don't forget you're subtracting another 2 pi, 1/4 plus 2/3. I'm going to distribute here. Four plus 16/3 minus 1/4 minus 2/3. And that's going to give me maybe makes it a little simpler. 4, looks like it'll be plus 14/3 minus 1/4. Let's see, 16 minus 2 is in fact 14. Yikes. Okay, well, 12. It looks like we're going to multiply the bottom by 4, top by 4, then by 3. This would be 12 over 12. 2 pi. So you get 48 over 12 plus 56 over 12 minus 3 over 12. And we'll do some arithmetic here with that. Hopefully that adds up. What is that? 48 plus 56 minus 3 is 101. 2 pi times 101 over 12. Six. All right. Looks like arithmetic is okay. Let's check these messages that are coming in. All right, just checking my messages now. Okay, we're gonna try number. We have some time here. Maybe we'll do one more. Just show you how, when you start to look at these bounded regions, like this is x equals y minus y squared. So you were saying x is a function of y here. They write it as g of y, right? So you got your curve and the y-axis. That's the line x equals 0 here. Okay. So I got the curve. Something's bothering me here on this one. I think they should say on the x-axis as well. Looks like they forgot the phrase x-axis. That's the line y equals 0. And that's this right in here, by the way. I could color it. This is the y-axis and the x-axis. This looks to me like the bounded region they're talking about. Okay. And they want to rotate about the line y is -1. So this is the line y equals -1. Now, I could do some algebra, right? Let's take a look at these lines here. They look like they're pretty good. I could do the algebra and show you this is going to be 1. So what I mean by that is we're going to integrate 2 pi RH. This will be dy. And y is going to be between 0 and 1, so we can put our limits there. So in the picture, we can see this bounded region, and that's going to be rotated about the line y is -1, so that approximating rectangle will be way over here. We get that cylindrical shell, if you guys want to look at it that way. And maybe it becomes somewhat of a distraction for you. But again, we need the radius and we need the height. So which is easiest to get? I think the height is easiest to get because this is the height of this rectangle, and the height's going to be the right value minus the left value. So I can't get that. So it's going to be the curve, which is the y minus y squared curve minus the left value, which is 0. Okay, so what I'm saying here is it's going to be this point minus that point. That's the y-axis. That's x equals 0. So it's xl minus xr, left minus right. Point being, the height is just y minus y squared. That's the easiest to get. Y minus y squared is your height. Okay. Your radius now. Remember, you're revolving about the line y equals -1 now. So if you said, well, what's going to be my radius value? Well, your radius is going to be this is the value y is -1. Think of it this way. Top minus, this is going to be a y value down to -1. Top minus bottom. Your radius is that y value here minus -1. Top minus bottom. I don't know what colors. Top minus the bottom value. So now your radius value here will be just y plus 1. Yeah, absolutely. Not too bad. All right. So to 1, 2 pi y plus 1, y minus y squared dy. So we can pull this out, 2 pi. So to 1, y plus 1, y minus y squared dy. You get to use FOIL here. For algebra. So let's make sure we don't screw that up again. First term. Outer term. Inner term. Last term. And it looks like if we are correct, your y squares cancel. So I'm just going to put what? Y minus y cube dy. Yeah. All right, looks good to me. We're going to integrate. Let's just integrate then. 1/2 y squared. That's 1 to the 4th, y to the 4th. Evaluate from 0 to 1. Okay, let's do some arithmetic. 2 pi. Now this will be, looks like it's 1/2 minus 1/4. So let's do some subtracting of some fractions here. Use your shortcut method. I'm Jesus. This is not. All right. 2 pi. This will be 4 minus 2 over 8. 2/8 or 1/4. 2 pi times 2/8, 1/4. Your volume is pi over 2. Okay, looks pretty good to me. All right, our time. We have time for one more. We got the time for the last one there. I don't know what that is. That's a little typo. Okay, from this picture again, it looks like you got x is a function of y here. And now you got the y-axis, which is x is 0. You're involved with this about the line y is positive 1. So let's see. Yeah, it looks like we have that. All right. It does look good to me, at least this picture. I don't even know what this is, so ignore that. Okay. But the point is, this is the bounded region. You're going to now rotate that about this line. This is the line y is 1. You're going to rotate it about that line. Okay, so if you do let's write down the formula. Sorry. Now notice again, this looks to be 1. And we can find the intercepts. You know, we set that x equal to 0, meaning y minus y squared is 0. And that's the y-intercept, by the way, because this is the y-axis here. So y, 1 minus y is 0. Yeah. Y is 0, 1 minus y is 0, or y is 1. Sure enough, we get the y-intercepts by letting x be 0. And so, yeah, we're integrating from 0 to 1. So this is the bounded region here in blue. And they want us to rotate this. And when we do, you know, we'll get an approximating rectangle that's pretty close there because you're rotating on one of the limits there. Okay. So, yeah, cylindrical shells, by the way. We just need a radius value and a height value now. Right? Those two things here. So you might say, which one's the easiest to do? I think the height is easiest because it's going to be just the curve, y minus y squared, and that's your height. The radius, though, let's see if we can figure out the radius now. Remember, this is going to be some arbitrary y value. And we just need to know the distance now from that arbitrary y value to this line, which is 1. So your radius will be 1 minus y, because it is top. The top value minus the bottom value. Y minus 1. There you go. And we can pull out the constant now. So right in here, you use what? FOIL. First, outer, inner, last. All right, let's see if we can get this here. 2 pi integrate 0 to 1 y minus 2y squared plus y cubed dy. Okay. You know, we do it this way. Let's just do, well, okay. We're going to integrate now, okay? One half y squared minus 2/3 y cubed plus 1/4 y to the 4th. We're going to integrate that from 0 to 1. So this is going to be f of x. We need f of 1 minus f of 0. The nice thing about working with 0 is you shall see. 1/2 1 squared minus 2/3 1 cubed 1/4 1 to the 4th minus 2 pi 1/2 0 squared minus 2/3 0 cubed plus 1/4 0 to the 4th. This is going to be a 0. All right. 2 pi 1/2 minus 2/3 plus 1/4. So the LCM of 2, 3, and 4 is 12. So I'm going to say this is 6. Multiply 6 to the top and the bottom. And then a 4. And then a 3. 2 pi. 6/12 minus 8/12 plus 3/12. Let's do some arithmetic. 6, it looks like it would be 1/12. 6 minus 8 is -2, plus 3 is 1. Looks like your final answer is pi over 6. I mean, it's nice that it works out to some sort of elegant solutions here, but that's what I get. So anyway, ladies and gentlemen, I hope you enjoyed the demonstration of these, and I will send it to you. Thank you so much.